Hi, my name is Jean Marie, and this is video number 2 in the series on learning to write HomeSeer plugins. With this particular video, I wanted to go over the plugin architecture and bring that back to showing you how the HSPI template fits into that overall architecture within Visual Studio. I put together a quick little PowerPoint here. I wanted to walk you through some of the basics that I've picked up on and hope that you get some better idea by looking at the architecture. So basically there are three files that are used by used by your plugin that are HomeSeer DLLs that need to be part of your Visual Studio project. The template that we're using, the HSPI, automatically brings in those three files through a NuGet package, so you don't have to worry about that. But if you were building this from scratch, you would want to put those three files in your project or reference them within your project. The three files are the HomeSeer API DLL, the HSCF DLL, and the scheduler.dll. And those three DLL files and the associated libraries in them do various things, and I'll walk you through each of them. So the HomeSeer API, it is the main interface for your plugin. It has the iPlugin API interface that your plugin has to implement. That is the class basically that contains all of the different methods and properties that you also have to implement within your plugin in the HSPI class within your plugin. It also has a bunch of the enumerations that you'll see within when you're writing plugin code that you end up making calls to. These enumerations are different values for different settings for different HomeSeer configurations. The HSCF DLL and the associated classes there are primarily involved with the communications between your plugin and HomeSeer. You'll notice that your plugin sets up two-way communication over a TCP socket. It then passes that data using HSCF and the associated protocols within it. And it's based on the simple client server framework that HomeSeer leveraged from, I believe, a different company. Finally, we have the scheduler. That's the main application of HomeSeer itself. It has the logic of HomeSeer as well as classes, let's say, for IP cameras, classes for HS Touch, classes for the jQuery elements that go on a page, like buttons and text boxes and drop down lists and so on and so forth. So connections from the plugin. How are connections established from the plugin to HomeSeer and vice versa? So some of the plugin rules are that all plugins must implement the iPlugin API interface that's in the HomeSeer API DLL file that we talked about earlier. The plugin has to have a class called HSPI that implements the iPlugin API, meaning that HomeSeer looks for a class within your plugin called HSPI. That HSPI has to have a lot of the methods and properties that are defined in the iPlugin API interface. The plugin's HSPI class can directly use iPlugin API from HomeSeer API, but that is a monster. It has a lot of methods and a lot of properties, and you have to define them all and then send back what HomeSeer is expecting. Or better yet, like we're doing it with the HSPI template, it can derive from a class that derives from the iPlugin API in order to make the coding a lot easier. Let the derived the class that you're deriving from define all of the boilerplate stuff and the defaults, and then you then only make the changes that you need for your own plugin. The HSPI project on GitHub that was created by Alex Dresko uses this concept of abstracting HSPI in your plugin from the iPlugin API and the HomeSeer API in order to simplify the code by getting all the boilerplate stuff out of the way. And then you only do overrides for the things that you want different from the defaults that have been chosen for the HSPI template. The plugin runs as a standalone executable that communicates over a TCP socket on port 10,400. Your plugin has to be named capital HSPI underscore your plugin name. That plugin name really shouldn't have any special characters other than maybe a dash. Keep it really simple, and it has to be at the root of the HomeSeer directory. It's what HomeSeer looks for when it's starting up to see what plugins it has available in that root of its directory. There's certain methods that HomeSeer calls out of the HESPI class of your plugin by default. So things like its name, whether it's going to use a COM port, and other things like that, it looks for in the HSPI class. But again, you don't have to define them all if the class that you derived from has already done it for you. However, if the class that's done it for you, let's say uses a COM port and you don't want to use a COM port, you override that class and give it the values you want. So the HSPI template has all these methods and properties defined for you, like I said, and you only override the ones that you want to be different. Here is a visualization of how that deriving of classes happens. So again, the root of all this is the iPlugin API, which is housed within the HomeSeer API DLL. That's the full interface. That's what your plugin has to implement. If you're writing code from scratch, you have to look at all the properties and methods in there, and then implement your own plugin with a class called HSPI that inherits from iPlugin API, and then do all the stuff that it's looking for. That is a really big deal. What's happened within the HSPI template that we're using from GitHub is it creates a new class called HSPI base that implements the iPlugin API, that takes care of almost all the boilerplate stuff for you. But then they've created a second class called HSPI base 2 that inherits from HSPI base that takes care of the rest. It basically defines everything to where you have very little, there's practically nothing to define for any new code that you create other than maybe the name for your particular plugin. And this HSPI base 2 derives from HSPI base that implements iPlugin API. And then finally, we have your plugin name.dll, which implements a class called HSPI. That derives from HSPI base 2, which derives from HSPI base, which implements the iPlugin API. And here, all you do within this class is override the properties and methods that you want your plugin to be different from all the defaults that are defined in HSPI base 2 and HSPI base. Hope that makes sense. So the initialization of your plugin. What does HomeSeer go through when it's coming up? What does it look for in your plugin? And how should things be handled? When HomeSeer starts up, it queries the following properties: the name, the access level, the capabilities, the COM port, like I said earlier, whether your plugin supports multiple instances, and whether it supports multiple instances on a single executable. The idea here is that no work at all should be done on any of these properties. Define the property and return. Don't do any kind of code logic. Don't initialize any hardware. Just do what it's looking for and get out. Your code is going to exist somewhere else. You want to always return in and out as quickly as possible out of the things that HomeSeer is querying. Once HomeSeer has gotten the data it needs, it then calls a method within your HSPI class called init.io. Init.io is where the beginning of your code execution in your plugin, where that begins. That's where you want to initialize hardware, kick off a thread that does the actual work. But even within init.io, you want to get out as quickly as possible. HomeSeer won't stick around long in init.io before it bombs out. It expects init.io to return back very quickly, and if everything goes well, it expects an empty string back. So what you want to do here is start a new thread within init.io that does all the work, and then let the init.io return very quickly back to HomeSeer. Another thing you can do within init.io is request callbacks. You can tell HomeSeer, hey, anytime there's an event change, that device has a value update or a log update, let me know about it. You define your callbacks here in init.io. And again, like I said, you start up a new thread, let that do the work, and let init.io return control back to HomeSeer. And that's basically the end of the presentation. Let me walk you through what that looks like within Visual Studio. Let's exit here. Let's bring up Visual Studio. So within Visual Studio, we can look at the HSPI.CS class in the project that we had originally created, the example 1 project. There's been no code changes to this. You can see in here there's a line that defines the class named as HSPI, and then it inherits from HSPI base 2 like we talked about earlier. Let's go to the object browser and look at that HSPI base 2. So start with HSPI. So in our code, example 1, you'll see that there is an HSPI and that HSPI inherits from HSPI base 2. So when we go to that, we go to HSPI, and there's HSPI base 2, and it says HSPI base 2 inherits from HSPI base. You go to HSPI base, and there is the class itself, and look at all the methods and properties that it implements. You're going to notice something. If I go to look at some of the names here, access level, connected, name. If I go to the HomeSeer API, this is the DLL file that we talked about before, and I go to HomeSeer API, I go down to the letter I will see an iPlugin API. Look at the methods and properties in here. Access level, same. They're exactly the same as the ones in the HSPI base, and they'll have a name, etc. Because HSPI base implements iPlugin API. So you can see how all of the relationship between the different classes exists, from the HomeSeer DLL to your plugins classes. If we go back to hspi.cs, you'll see that in here there's just a single override. You'll see protected override string get name. And all we're doing is overriding the name property and returning our plugin name example 1 instead of whatever's in the HSPI base 2 or HSPI base itself. And we're overriding that property. On the next lesson, we'll go through and show you how to override other properties, like I said, the COM port and other ones, and start in the init.io and building the logic of our plugin. But for now, I think we'll wrap it up and continue that on video number 3. I hope this was useful. And as before, let me know if you have any questions or comments on how I can make this video series any better. Anyhow, hope you've gotten some use out of this. Thank you.